A very good morning to my dear lecturers. Today I am going to present on the second assignment, which is the design implementation of our project. First, we will look into the site analysis. The Academic Al-Quran is an academic institution dedicated to the study of the Quran. Founded by Zaima binti Muhammad Zain, the institution was inspired by the desire to formalize Quranic learning among the community's children. Its primary objective is to promote Quranic education through a variety of programs and courses focused on recitation. And also, it is classified under the Group 1 building classification, which is the institutional building. The site was initially established as an academic learning center similar to our current project, making it an ideal goal for our design. Additionally, the open space is well suited to function as a community hub. Our design implementation has been classified into several systems. The first will be the mechanical transportation system. The mechanical transportation system that we have implemented in our project, in our community hub, is the holeless hydraulic elevator. The power unit and the controller are located outside of the hoist wheel. The powerful controller uses solid-state technology, boosting reliability. The mounted user interface tool, which is UIT, that provides easy access to adjustments and parameters for maintenance and services. This holeless hydraulic elevator uses a silent pump station. The sound decibel is about 30 decibels. The pump station system will be placed 3 to 4 meters away from the elevator, and it is easy to maintain. There is no need for professional elevator maintenance personnel. It only needs to replace the hydraulic oil regularly. The components that we can be found in the holeless hydraulic elevator, which is aluminium alloy track, silent pumping station, electromagnetic lock of layer door, backup power, and the safety touch panel. Secondly, we will look into the prior prevention and protection system that we have used in the Upskilling Community Hub. The first will be the portable fire extinguisher system, that they will be located at the conspicuous places along ordinary paths of a grass. Fire extinguishers will be surface mounted on recess within the walls using a special cabinet with a visible panel. The extinguisher will be visible at all times, must be tested regularly, and must have an approval label. The second will be the monitoring system. This system connects the fire protection system to a central monitoring station, which can summon emergency services when needed. This ensures that the system complies with HEPA 72 standards. The third will be the fire pumps. These critical components enhance water flow to both the fire sprinkler and standpipe system, ensuring that the pumps comply with HEPA 20 standards. The fourth will be the standpipes and hoses system. Standpipes or water pipes will be extended vertically to the building to supply fire hoses at the both floors. The next will be the fire sprinkler system. The sprinkler head locations should provide adequate clearance at each sprinkler. Typically, a minimum of 46 cm must be left open below the sprinkler head reflector. And the next will be the automatic fire alarm system. The fire alarm system includes equipment for signaling that there is a problem, for processing that signal, or for alerting people as for the situation. Automatically initiates and activates the alarm when it detects fire, smoke, or heat. And the last will be the exit signs. The exit sign will be placed at the exterior exit door or area when the direction of egress is unclear. Within an exit access, the maximum distance from an exit sign is limited to 30 meters. And the third we will look into is the security system. There are 4 types of security system that we have implemented in our hub. The first will be the most important, essential, which is the smart security camera. The second will be the wireless sensor security alarm. The third will be the fingerprint access control system. And the fourth will be the centralized management and monitoring room. We will look into the accommodation for the building services. Each of the pipe ducts has been sealed with the ends with a plastic filling and mastic sealant. The type of accommodation system that we have used is the suspended and false ceiling. For an example, secondary ceilings are suspended from the structural floor slab above, creating a void between the underside of the floor slab and the top of the suspended ceiling. This void allows for the accommodation and concealment of building services. Additionally, a suspended ceiling enhances the fire resistance of the structural floor. False ceiling systems are constructed in situ using metal framing, creating a great support system that accommodates loosely fitting ceiling tiles. The sixth will be the alternative and renewable energy system. The types of the system that we have used is photovoltaic panel working mechanism. And the process of installation, the first is the installation of the PV panels, where the photovoltaic PV panels will be placed on the roof, if possible facing northeast, so that they are able to capture the most energy possible. Second will be the collection of sun rays. The solar panels of the roof collect the sun radiance during the days. They made of silicon and only need the sun's radiance to work. So even as the cloudy days, they will be able to generate power for the hub, albeit with lower production than on clear days. The third will be the conversion to the DC powers. As the PV panels collect the sun rays, they convert them into direct current, which is the DC electricity. The fourth will be the conversion to AC power, which is the inverter. This DC is then sent to the inverter, which converts the DC power into alternating current, which is the AC electricity. The fifth, the last, will be the power is sent to the interior, to the community hub, which is the converter. AC power is then fed into the building's wiring system, where it all power the lights and the appliances. The next we will look into the acoustic system that we have implemented. The first will be carpet. Carpets, regardless of their density, looping and depth, particularly when combined with additional padding, provide significant absorption in the middle to high frequency range. The second will be acoustical ceiling panel tiles, where the acoustic ceiling panels manage noise control by reducing noise levels in both large and small areas, ensuring balanced acoustics for occupants' comfort through sound energy absorption. Suspended ceilings provide soundproofing qualities and can conceal existing damage, as effectively hiding exposed ducts, pipes, and wirings. And also, for the blocking noise, we have implemented the room arrangement. The arrangement of the building spaces are made in such a way that more sensitive areas like furniture making area are away from the noise, and the less sensitive areas like classrooms and the first floor. Thank you.